INPA is building multi-actor regional networks in Africa, which brings together institutions to carry out research on agroecology and foster higher education curricula and inform policies. And this will serve as something like centers of excellence on agroecology in the regions. And thirdly, lastly, INPA is co-chair of the Knowledge Center for Global Food Security and Nutrition, an online platform that provides curated knowledge on key topics, including agroecology. And within this knowledge center, and in collaboration with partners like CIRAD and ISARA and also independent experts, we've synthesized available scientific information on social, economic, and environmental benefits of agroecological practices in 5 comprehensive studies. And Dr. Maria Luisa PARACCHINI is the woman behind these studies, and I'm very happy that she will now present the latest 2 studies to us in this presentation. She is a project officer at the JRC, and in her work, she works on monitoring, assessment, and enhancement of environmental sustainability in farming. And issues like ecosystem services and biodiversity were really at her heart for research in the last 2 decades. Without further ado, I want to pass the floor to Maria Luisa, who will share her insights and expertise with us in the next 30 minutes. And afterwards, we will have time for some questions and answers. Over to you, Maria Luisa.
Thank you, Carolina, and good morning and good afternoon to everybody. I'm going to guide you through the results of the studies that we have carried out with the support of the experts, and you will see their names in the slides. These studies were carried out at the global level, are based on an analysis and synthesis of existing scientific production. I will focus here on the latest studies we carried out on the socioeconomic performance and the performance of agroecology in respect to climate change, adaptation, and mitigation. But in our analysis, we have also targeted food security, food systems, and the links to sustainable development goals. And you will find the link to these other results in the last slide of this presentation. Next, please. In the studies, we aim at retrieving detailed information from available literature concerning interaction of agroecology with specific components, whether environmental, such as climate change, or socioeconomic. And one of the methods to browse through digital repositories of literature in an organized way is to apply a systematic literature review. So this is what is behind our studies. This is a method based on strict protocols to retrieve and screen existing studies and synthesize and interpret results. The process starts with the identification of the topic to be researched and a suitable search string to identify relevant literature. In our case, we looked for studies including a direct comparison between systems adopting agroecological practices and conventional systems. And this search in this sense was really strict. And this explains why the number of retrieved studies at the end is relatively small compared to the initial pool. Next. I'm not seeing the slide appearing. Next, Carolina. This is okay. Thank you. Thank you. You see here to the left an example of a search string. In the case of agroecology, it is necessary to widen the search, including farming approaches that are including the agroecological paradigm or parts of it, such as ecological agriculture, regenerative agriculture, to be able to identify all relevant papers, because though the term agroecology was coined a century ago already, it's only recently that it has been gaining attention and has entered into a more common use in literature, let's say in the past 10 to 15 years mostly. Before then, agroecological systems may have been defined using other terms. The graph to the right shows both the temporal evolution of the number of papers using the term agroecology in the title in green, and all the terms listed in the search strings. And so you see the difference. The second part of the search string is related to a specific theme under the analysis. In this case, is the economic impact. And so the second part changes according to the topic analyzed. The papers that's retrieved are screened to eliminate those that do not represent agroecology, since you may find here examples of intensive systems. For example, if we search for mixed farming, we do not find necessarily only agroecological approaches. In the selection process, only articles that present the comparison with conventional are retrieved, and where both the analysis of both systems is carried out under similar pedoclimatic conditions and land use systems. These reviews encompass a broad range of outcomes, and the outcomes have been categorized as positive, negative, neutral, or inconclusive. Positive are assigned to those metrics where agroecological management systems have yielded a more favorable result in comparison to conventional ones. For example, a higher carbon efficiency ratio or a higher carbon stock. Conversely, negative outcomes are assigned when the metric of for agroecological approach has demonstrated a less favorable outcome. So it's a binary way of retrieving the result. Positive counts for one, negative counts for one, and so on. Then we have the neutral outcomes when there are no significant differences in results, and inconclusive when you have contrasting results. So you may find positive in some papers and negative in others. Next slide. So, not next. The first study provides insights in consolidating evidence on the varied socioeconomic effects of agroecology across a large number of cases at the global level. Next. Here, the screening started on 13,000 papers. So these were retrieved from the search string to identify 80 papers in the end with the comparisons to conventional agriculture for a total of 125 individual cases of comparison. In this case, supervised machine learning was used in the screening of primary studies. And we are also now exploring the use of AI because this first phase is really time consuming. So interestingly, 81% of the articles was published between 2011 and 2022. Next. We see here which practices and systems are analyzed and on which we have knowledge. Almost half are agroforestry. Intercropping corresponds to 19%. Cropping system diversification to 10%. Tillage practices to 7%. We also find enhancements of ecosystem services such as natural pest control. And interestingly, also 64% of analyzed articles were actual on-farm implementation cases, and 36% were on-farm intervention studies conducted together with farmers. Next. So there is no single indicator to represent the socioeconomic performance of agroecology. Instead, it is captured through indicators that reflect its dimensions, structured according to, in this case, it was a choice of the authors, of the experts, capital categories: financial, human, social, and the relative dimensions describing these three capitals. For example, profitability and resilience to describe the financial capital, and then you see in the list the other categories. This is organized in tiers, as you see. An indicator can be represented by many different metrics. There's not necessarily only one that you find in the papers. And in the table, you see, just to give you an idea of the work that needs to be done when you need to refer a paper to one of the dimensions. You need to identify the metric and understand where it fits, actually. So once this clustering has happened, since each metric represents a result, this then can be accounted for with reference to the correct category. Next. Next slide. You see here the other dimensions, labor demand, productivity, and conditions to describe human capital. And well, I'm not going to read the rest, but you can see in the presentation that remains available. Next. So we see here the results. Overall, agroecological practices are associated more often with positive socioeconomic outcomes across the broad range of evaluated metrics: 51% positive income outcomes, 30% negative, 10% neutral, and 9% inconclusive outcomes. A large number of metrics indicate positive outcomes with respect to aspect of income and efficiency, productivity. Revenues and income stability are also mostly positively affected in a majority of cases. Within the human capital category, we found an almost equal split between positive and negative outcomes. And we find here results pointing to a higher labor demand for agroecological practices, as well as the need to pay attention to production costs, including organic fertilization. This type of presentation of results provides also information on knowledge gaps. It's evident from this graph that the social capital component is underrepresented in the results, as well as indicator describing resilience. Next. So the previous slide is synthesizing the general results, but we also have results per individual systems, farming systems, or groups of practices following the same methodology. And among others, in these slides, you see results for agroforestry specifically, and intercropping. And also in this case, you see a dominance of positive results. Next. So in conclusion, we can say we have to point out most examples concern the global south. This is not always the case. We will see in the next study. Overall trends are positive, but there can be strong variations depending on the parameters analyzed. There are higher share of positive outcomes for income, revenue, and efficiency, productivity. Agroecological practices are found to be associated with higher labor requirements and costs in many of the evaluated cases, but also potentially higher returns to labor compared to conventional practices. Interestingly, production costs were associated with more positive outcomes, but this was not the case for several of the explored cases, and the effects were not uniform across the different phases of the transition. In analyzing the results, one has to pay attention to issues such as establishing ecological infrastructure in the farm is costly at the beginning, but after 3, 4, 5 years, the ecological services start to be at the service of the farm and production. And so these costs then are widely reduced, and when functional biodiversity starts to provide its services, and the maintenance costs are decreasing. Nevertheless, depending on the farming context in different parts of the world, we see higher costs at the beginning of the growing season. So for seeds, organic fertilizers, and other inputs. And this, again, to stress the fact that we always need to analyze in depth the results to understand what they mean. Because having these costs at a certain moment of the growing season means that farmers need to have access to cash or credit. Further example is an increase in yields and land productivity at the feed level, accompanied by improved farm incomes and labor productivity. And as I already said, higher labor requirements in many cases. Next slide. Financial capital category is the one that is most assessed, with 83% of the total number of metrics. There were no identified metrics for market access, marketing chains, employment opportunity, working conditions, and gender equality. So this has to be stressed as a knowledge gap at this stage. Further research is needed to embed the social science research on a large set of concepts related to the agroecological transition. And there is also a need for wider systemic studies, which require longer research periods and long-term data collection. Next, please. We move on now to the result of a second study addressing climate change mitigation and adaptation. This is split in two. So we start with mitigation. Next. So here we have reached a bit the edge of the method for this kind of approach, because we started with 16,000 papers, and this is really really demanding to be screened. So it's when we realized that we need to move towards an automated way of screening the papers, at least to eliminate quickly, but with a high degree of accuracy, because we cannot risk to not to take into account relevant papers. So to do this as much automatically as possible, so through machine learning or artificial intelligence. So here, what in the end, the screening phase that was passed by 162 papers. We had 146 for mitigation, with 305 comparative studies, and 16, and I will come back on this, for adaptation, with 33 comparative studies. Next. So again, it is always interesting to see which kind of systems are mostly represented in literature. In this case, it is conservation, organic, diversified systems, while other specialized systems, including agroforestry and climate-smart agriculture, are much less represented. The majority of the comparisons focused on rice and arable cropping systems for 33% of cases. These are based on maize, wheat, and soybean in almost 40% of the cases. And we had very little representation of dairy, mixed, and other non-food crops. Next. So in these coming two slides, we see a summary of the type of comparison that was possible, given the information found in literature. So we have to the left the list of conventional practices taken as reference, and on the right the agroecological alternative, which is represented also by different transition level, because to each of these practices, we can associate a degree of transition, whether increasing efficiency or substitution or farm redesign. Next. So you see the rest of the slide. I'm not going to read this. It will remain available. Next. Sorry, the rest of the table. This table, so as in the other study, in order to be able to assign the metrics to one of the study dimensions, it is necessary to build a framework for the indicators. So in this case, the framework is this that you see here. And it is showing the mitigation indicators expected to be encountered and analyzed in the review. Given the objective of the study, the framework is broken in three main domains: the reduction of greenhouse gas emissions, the absorption of these gases in different forms in the soil, so sequestration, and greenhouse gas balance. And this again is organized in tiers, so it's divided in indicators, categories, subcategories, and the attached metrics. Next. So, as in the case of socioeconomic study, the results are presented distinguishing statistically significant results. I have not explained this earlier, but you may have noticed that we keep this distinction between what is statistically significant, so it has been tested for significance, or not. This depends what the papers are providing as a result. In this case, within metrics analyzed with statistical tests, a large number of outcomes, 53.2%, was significantly positive, while 14.6% had negative, and 1.7 inconclusive results, respectively. More than a quarter of the metrics, around, well, not around, but precisely 30.5% showed no significant difference between conventional and agroecological systems. So the graph shows as well that fewer studies are available comparing examples of carbon sequestration compared to emission mitigation. Next. So overall, the results of this review confirm that climate change impact from agroecological practices is context depending, but showing overall more positive outcomes than the conventional counterpart. Greenhouse gas emissions were vastly measured by soil fluxes. However, few of them considered energy or fuel as well. Practices that focus on soil management are found to mitigate emissions largely. For statistical significant results, rice stands out as the predominant cropping system that is responsible for some negative outcomes, majorly contributing to increase in CO2 and methane emissions. For crop-like stock system, all outcomes were neutral, and the impact of climate variability was found as a factor to be kept into consideration because, for example, corn has a variable outcome in terms of greenhouse gas emissions depending on the precipitation rate. So in dry climate is lower than in more humid meteorologic situation, let's say. So also this needs to be considered and taken into account. Next. Then to be considered, input on farmyard manure and green manure were reported to have significant negative outcomes for methane emissions, and this can be attributed to a low carbon nitrogen ratio of organic manures, which resulted in faster mineralization and consequent higher emission rates of methane. Soil organic carbon sequestration was analyzed in a small amount of studies compared to greenhouse gas emission mitigation. So these results always have to be contextualized to the number of papers that are analyzing the topic. So this is why we prefer to present the results with these bars rather than in the circles that I have shown in one of the slides, because if we talk about percentages, we don't have the perception of how deep is the knowledge on that specific issue. Next. And this is the last part on adaptation. Next slide. So this table presents the framework that was constructed for the identification and selection of relevant papers presenting evidence on adaptation. There was no suitable existing framework was identified for applicable to our scale of research, that is the field, the farm scale. So the framework provided by the FAO Tracking Adaptation and Agricultural Sectors Framework was taken as a reference and modified to be fit for our scale. You see here the framework in this slide and in the next. So there are these main indicator category: socioeconomics, institutions and policy, and the natural resources and agricultural production systems. Next. So overall here, as I said, the papers were only 16. Despite this, we identified 33 comparative studies contained in the paper and 257 metrics. The majority of the metrics fell under the agricultural production system category, almost half of them, followed by the natural resources and ecosystems, 45%. The socioeconomic category accounted for the remaining 10%, and institutions and policy was not represented at all. Within the metrics analyzed with statistical tests, nearly half demonstrated a significantly positive outcome for the agroecological multi-practice combination compared to the conventional counterpart. while 11% showed significantly negative outcomes and 8% inconclusive. Approximately 1/3 of the metrics showed no significant difference between the two counterparts, let's say, agroecological and not and conventional. The majority of the selected studies, 60%, involved a combination of at least two agroecological practices, and 1/3 of them on three, and only 8%, almost 8%, 4 or more practices. So this I have not explained already. We don't take into consideration papers that are addressing one practice only, because first, literature is wide on this, and it's not the topic of our research. So we are trying to move along the transition gradient, trying to see what entails uptaking groups of practices, if not a whole farm redesign, so more practices. So this evaluating agroecology systems within broader context, we need to reduce the risk of having too few practices to represent agroecology. And in conclusion, the next slide, please. So significantly positive outcomes actually present in literature are almost half of the results that we found. 11%, as I said, are significantly negative, and 31% not significant. Socioeconomic metrics were underrepresented, but showed the highest proportion of significantly positive results, with 64% of metrics showing beneficial results. Next. Most existing frameworks focus on national and territorial scales. There is a lack of comprehensive framework tailoring farm and feed levels. The majority of studies focused on practices central to conservation agriculture, such as reduced tillage and residue retention. More advanced stages of transition, such as crop livestock integration or inclusion of landscape elements, were not often studied. Constraints such as access to affordable land, institutional difficulties, for example, for administrative license and certification, and lack of financial support, are mostly considered as the factor determining a low complexity of agroecological practices combination in real farms. I can conclude now with the last slide with some point for discussion, because here we analyze knowledge and knowledge gaps as well. So the amount of retrieved studies is overall relatively high in these studies that I presented and in the others that we have carried out. And overall, we can now say that there is a relatively small number of studies of direct comparison compared to the initial pool of studies. Very, very small, a small number of papers is containing information on long-term monitoring. And this is mostly deriving from the fact that projects normally have a lifetime. And once projects are finished, monitoring is also ending. There are a small number of studies on systemic approaches, so more easily you find comparison of, as I said, one farming practice a lot than 2, 3, 4, but less on like agroecology with a nice description of what it entails. Small number of whole farm comparisons. So there are more studies on field at field scale than at farm scale. At farm scale, this also normally includes an analysis, not always, but may include the analysis of the agronomic performance and the economic performance, for example, that would give a picture of what are the outcomes of an uptake of an agroecological transition. And social dimension is definitely underrepresented. Not in general, I always have to stress in this kind of comparison with the conventional. Mitigation and adaptation studies applied to agroecological systems are turned out to be two distinct fields of research, leading to scarce examples of coupled studies. But this in the end may not be really a problem once we can we can transfer the results from one field to similar areas. So in order to rejoin adaptation and mitigation. And with this, I conclude my presentation, hopefully within the time limit.
Thank you very much for this very good overview. And I think in your last slide, you already mentioned lots of questions that are worth discussing here. And I encourage you to put questions in the chat that we then can pick and give to Maria Luisa to see if there are answers in the studies. Of course, probably the studies will not be able to answer everything. But I saw that we also have 2 hands raised, but I don't see that again. But just put your questions in the chat, and then we see from there.
I see a question, for example, can you explain the main gaps in the studies? Lack of interest of funders. It's difficult to answer this question. I think for example, concerning the social studies, what I have seen in my personal experience is that like over 2 decades ago, studies in the environmental dimension were carried out sort of standalone. So there was more the silo, environmental, economic, social. Then we started to, so I come from the environmental dimension, to move and talk to the economists. And this has got more and more consolidated, while the social part arrived a bit later in this more overarching view of sustainability in the end. So I think there is also a lack of history of common working and trying to find a common ground, for example, to identify indicators and monitoring, insert questions in surveys so that the results can be used this way. So I think it's also that, and that the social part is not that it's not existing, is that it's going on in parallel.
So maybe we pick some more questions. Let me pick the one of Wisdom Madede. She is asking if you could also analyze with your methods trade-offs and between the different outcomes.
So this is a very good question, and that we already have asked ourselves. So this kind of analysis, the aim was to provide a first feedback on the capacity of agroecology to answer some questions. So, for example, in the socioeconomic domain, there was not much literature at this scale proving that the outcomes can be positive. Globally, I mean, if you take the overall approach, different areas of the globe, different environments, but it's a sort of binary. So as I said, you count positive, negative, and you don't know if it is a bit positive or a lot positive. So what we have started to do now is to dig into the quantitative data. So to retrieve the numbers, basically. And once we have the quantitative data, then we can carry out the trade-off analysis, because with the value of the metrics, then this is possible. So I don't have the answer now. Something can be retrieved from literature, because the papers analyze this kind of things. So we have in our publications, we report the as I said, we are trying to explain why you have more emission of methane in some situations. It's due to rice, it's due to well, to the presence of water, to certain biochemical phenomena, these kind of things. But to have really an overarching view on the trade-offs, we need the quantitative data.
So let me ask a provocative question by, no, it's gone, sorry, Jim. It's always going when I have it. So Jim Hancock, who asked, is there the possibility of underlying bias where agroecological studies being picked in deeper research may have focused on more successful or comprehensive efforts? So could there be a bias? How do you see that?
This is also a very good question. I think this is probably a question for all published literature, because I think scientists are happy to demonstrate that something works overall, I mean, in general. So I cannot answer like yes, there is a bias, how big it is, or no, there is no bias.
Mm-hmm.
We should investigate the like the willingness of researchers to publish a research where you say, yeah, we looked for this thing and we did not find it.
Hmm.
Yes, this I cannot really answer this.
Yeah, these are tough questions. Huh?
Yes.
So Christian Bienig also asked a question, and he asks about the currencies or basket of currency, which is calling to the metrics,
Mm.
how we measure progress, if it's financial, human, social capital, but also for CH4 emissions, soil quality, water use. How comparable are these results, and should we be exploiting more in depth all of these until we have a better understanding or agreement for comparison?
And we go back here to the fact that this kind of studies, I think, give a direction and give quite a solid understanding that there is potential, and like proposing agroecology as a way forward. It's it's possible, and it's feasible. But then if we want to like collapse it on the ground and know what to do where, then we need to go and study the details, which are exactly this in the question. So we need to move to have information per geographic area, more delimited, to analyze which are the farming practices that work there, or the farming approaches, and have a clearer idea of the trade-offs. And this using this kind of approach. Then there are other things that can be done, but now I remain in the in the silo of this presentation. We can have it with the numbers, so a more in-depth analysis of the quantitative. Because if we take the quantitative side of the story, then we can use directly the currency values, for example. Here, I mean, here this presentation, this works are a way to bypass the problem that you have different unit of measurements in the metrics, because you take the meaning of the result. So the result is positive, it counts as positive. So you don't have to worry if you have euros on one side and kilos or tons of or grams, let's say, of carbon on the other, because what counts is that it's positive. So it's an approach to the analysis, but we have to be conscious of the boundaries in the use of the results.
Yeah, there were also some more questions going more deeper. And as you already said, we were probably not able to reply to these questions. How the differences, for example, are among different regions would need a different study and more in-depth analysis. Or also here.
Here, there are some answers in the other studies that we have done, so attendees can find in the link at the end of the presentation, because we have analyzed, for example, agroecology per country. We have a number of analysis.
This was related to food security, yeah?
This was related to food security.
Yeah.
So agroecology related to relation to food security, but analyzed per country. So there you have a specific view on what is happening in certain specific environmental and socio-economic and even political or governance situation. This is always possible given that there is literature, because these works are based on existing scientific knowledge. We can draw conclusions if this knowledge exists. So this is the bottom line, let's say. And on the other hand, pointing out, I think this kind of approach is really useful to point out the knowledge gaps. It's equally useful to provide, to know what we know and to know what we don't know, because I always hope that by pointing out the knowledge gaps, then there will be research projects or interest in filling out these gaps. And also, last thing, it's relatively recently that we can use these approaches. It's since the digital repositories of scientific literature are available, and we have the means also in terms of IT to browse through them. So it's a sort of, still I consider it a sort of prehistoric era that we are building and pointing out knowledge gaps that were not so much visible before. It's a great value added.
So Agnes Balzani asked if you could pick out 3 knowledge gaps where you say these are the most important ones to investigate, which one would that be for you?
Oh, excellent question. Let me see my conclusions. Well, an important thing would be to go for the systemic approaches, so to analyze really the whole farm and not only a field. Then to try to cover as much as possible different areas of the world, because I don't know if you noticed in one of the slides we had put the map of the globe with the points where we retrieved the studies. And in that case, that was adaptation. You see that there is not much on adaptation in the African continent. So that is definitely a knowledge gap. And long-term monitoring. Long-term monitoring is important, because if you start a transition, it is known that the agroecological transition for a farm takes some time, and so we would need to monitor a certain number of years to really see the performance.
Okay, thank you very much. There were a few other questions. I just read that out for you because I really don't know if this is something very specific. So if you consider RCT and cross-sectional observational data, if there is any significant difference to what you did, but I'm not so sure I know what RCT is.
RCT. I see the question, but I know I don't know what RCT.
And the cross-sectional. So probably there is a lot of cross-section in the studies that we did, but
again, from the quantitative data, this will become more evident, I think.
okay. So what we will do in the further studies to come is to really go deeper into the agroecological practices and see how they affect. But maybe you want to say a little bit on this, on the studies we are starting now. What be the question?
So yeah, no, the question is to be able, or the final question would be to check what happens when you uptake more practices at the same moment. So we start from 2, 3, 4, 5, 6, and to see what changes, if there are outcomes that are improving, or trade-offs. Trade-offs are important, but let's say the aim is to see what happens when you go along the transition, different stages of the agroecological transition.
Okay, so we got lots of answers what the RCT is. So it's the randomized control trial.
Okay. Okay, yeah, yes.
So sorry that we didn't understand the abbreviation right away. So this was not done in that study. So
no, not yet, no.
Okay, so thank you, everyone. I want to pass the floor to Francois. I think maybe Francois, you want to say something on this on the way to go.